Hello lads, just a quick one on the enlargements. Okay, so again, it's probably overlooked Enlargements. Okay, enlargements. So it's probably overlooked a lot. Okay, but it's the kind of thing if it comes up and you don't know what to do, you're kind of having a clue. So listen, I have two triangles. Let's say there's ABC, and then this is A prime, sorry, B prime, C prime. Okay, and we got this one by enlarging this one. Okay, so let's explain the concept. So first of all, we need to know how it was enlarged. And usually, if you have a ruler, you can map from one onto the other back to a point from which it was enlarged. So as you can see, I'm mapping back. I don't know if this will stretch, but it probably will. So, sorry, a little bit off there, but you get the idea. I hope you do anyway. I can always adjust accordingly to fix that. So, this original one, if you map from some imaginary point, if you were to shoot out a ray of a line, it would go through the point, the original vertex, and the new vertex, and conversely. Now, what you notice is that in this case, in triangles, these are similar triangles. They're not congruent, but they're similar. In other words, they share the same angles, and obviously their sides are being ratio to each other. Okay, so this is called the center of enlargement. I'll show you another one in a second, center of enlargement, and that's basically how you find it. It's by mapping back using rays from the image to the original. Okay, so used in a kind of a physics term, okay, this would be an image. This would be an object, and these would be rays. So I'm just using kind of optics from physics. That's the best way to kind of explain them for anyone. Okay, so enlargements. What exactly has happened? Okay, so I'll show you another one. So let's say we have this object, okay, and we want to enlarge it. We want to double it, okay. So we want to double the object. Okay, so watch what I do. Measure one side and just scribe a line up there. Measure one diagonal and just scribe a line up there and measure again. And just scribe a line out here. Now, what are you thinking? What's going on there, sir? So, let's say the center of enlargement here is at this point A. So all I have to do is just shoot a ray straight up through that point, and through that point. Join the three new ones. And now we have a very large rectangle and a very small. This is the image one, and this is the object one. Okay, and if I want to figure out how it's been scaled, all I do is just measure one side, let's call that 60, and then measure the corresponding on the image, 30. Okay, so image divided by object is equal to scale. Okay, so in this case, if we are working from the bigger one down to the smaller one, the image was 30. The object was 60. So this was scaled down by a half. If I was working from this one up, then it'd be the other way around. The scale factor would be up by 2. So whichever way you look at it, if the image is smaller than the object, the scale factor is going to be a number less than 1. Conversely, if it's the other way around, if it's bigger, then the scale factor is going to be enlarged, basically. Okay, so how does that affect the area? Okay, so I'm going to show it to you on a grid sheet. So it's going to draw 4x4 grid. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that has an area of 16. Okay, 16 square units. Okay, so let's enlarge this then. Okay, so let's enlarge it by a scale factor of 3. Okay, so it's 1, 2, 3. So it's going to go up to that height, and it's going to go across. Scale. It's going to go across to there. Okay, and same thing here. 1, 2, 3. So let's pop our new one in. Right, so let's put down all the information we know. This is our object, and this new one is our image. Let's work out, first of all, the scale factor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the scale is always going to be image over a corresponding 1, 2, 3, 4, which is a scale factor of 3, which is what we said at the start. Okay, so there's nothing new there. Scale factor of 3. So let's work out the area. So the area of the original, the object's area, OBJECT, was 4x4, 16 square units. This one, it's going to be 12x12, so the image is equal to 144 square units. Okay, now the real question is, I got a calculator for this. Find a calculator. Bear with me. Right. So, $16 is a factor of 144. Okay, so interestingly, 16 goes into 144 9 times. And the relationship between 9 and 3 is that it's squared. So in other words, the area of the object multiplied by the scale factor squared will be equal to the area of the image. And just to show you that's true, the area of the object is 16 multiplied by 3 squared is in fact 144 square units. Okay, so I hope that makes sense to you. Okay, and that's all you really need to know about two things: how to work out the scale factor, which is usually referred to as K, and then what's the relationship between the scale factor and its area. Okay, best of luck.